Hello, my dear friends. Let us resume our journey to this drone pilot training course. And now we shall be discussing the fifth chapter, which is about multi-router drone operations. In this chapter, I shall be introducing you all about the brief history of the drones, the various types of drones, and we will also discuss about the drone anatomy by taking an example of a quad pop. We shall also be discussing about the inner electronics used to make that drone, a rotorcraft drone. We'll also look into the some aspect of mission planning, followed by applications, merits and demerits of multicopters. So let us begin this session. Before we discuss about the drone history, let us familiarize ourselves with some basic drone terminologies. Maybe sometimes you will notice there is a repetition of some drone terminologies that we have already gone through in previous chapter. But I feel this is important if some terms repeat here, because it will help you to memorize these words, and it will get settled in your mind and you will start feeling comfortable with these terminologies. UAV, full form, is the Unmanned Aerial Vehicle. UAS stands for Unmanned Aircraft System. SUAS stands for Small Unmanned Aircraft System. RPAS stands for Remotely Piloted Aircraft System. Quadcopter is a drone having 4 rotors positioned on a horizontal plane. Multicopter is again a drone with multiple propellers. Here, multiple word specifically means any drone that has more than 2 rotors installed on it is an example of multicopter. Hexacopter means a multi-rotor drone having 6 rotors, and octocopter means drone with 8 rotors. There is a term RTF, which you may sometimes find it over internet, which is related to drone, and RTF stands for ready to fly drones. There are some drones which are available in the market which are ready to fly. It requires almost little or no assembly. There is a similar term, ARTF, stands for almost ready to fly. These drones require some minor assembly and additional equipment. Example, receiver and radio transmitter may be required to fix with it, and radio transmitter is also known as a radio control. Bind and fly, BN. This term stands for drone models, which are basically RTF drones, ready to fly drones with a receiver. You must purchase the radio controllers separately. FPV stands for first person view. The video feed which a drone pilot gets directly from the camera of a drone is a first person view. Return to home, RTH. This is a kind of safety feature which allows the drone to automatically fly back to the original takeoff location or its starting point. Gimbal. Gimbal is refers to a mechanical camera stabilization component. This gimbal helps the camera to take stable pictures and videos during the flight, and the clear videos and the smooth video which you get from gimbal is remains undisturbed even during when the drone performs any different maneuvers during the flight. So this is the important function of a gimbal, to stabilize the camera. There is a term headless mode. Headless mode may be available in your unmanned aircraft system, which is for beginner pilots. Using this mode, the drone will always travel forward, backward, left or right. When moving, your remotes stay in their respective directions, regardless of which way the front of the drone is facing. Yaw. Yaw is a term that refers to a rotational motion of it about its vertical axis. Okay? You may assume there is an axis, imaginary axis, passing vertically downwards through the drone, pointing down towards the you can say center of the, and this vertical axis, if any drone performs a rotational motion about this vertical axis, so that is known as yawing. So drone may rotate clockwise or anti-clockwise, and that will be referred as yawing motion or a yaw motion. There is a another term, pitch. Pitch is again a kind of rotational motion of the drone about its lateral axis, and this motion is not very high in its angle. It is just a kind of little deflection towards or upwards about its lateral axis. And while performing this rotational motion, a drone can move forward or backward direction. The roll is another rotational motion of the drone, and this motion takes place about the longitudinal axis. This rolling motion allows the drone to translate in the rightward or the left direction. So this is very important to understand here. One is the vertical axis that you can assume passing vertically downwards through the drone. One is the axis that can be assumed in this direction. You can say just perpendicular to your screen, and that axis is referred to as a longitudinal axis, and the another axis is the lateral axis, which is in this direction. I have already talked about these axes in the previous 4th chapter while discussing about the fixed wing operations and its aerodynamics. Autonomous flight. Drones that are managed by internal programming have instructions on where to fly. These types of drones that have autonomous capability are guided by onboard GPS system. BVLOS. This BVLOS is an abbreviation for Beyond Visual Line of Sight Operations. LiPo, LiPo, it stands for lithium polymer. This is a type of battery which most of the drones currently are using. Payload is the term that refers to the amount of extra weight that a drone can carry, in addition to its own weight of airframe and its battery. Let us look into the detail of the term drone. A drone term can be accurately defined as it is an aerial, ground, on underwater vehicle, which is without a human pilot on board. It can be controlled either remotely or autonomously. Sometimes these drones are also referred to as UAVs, that means unmanned aerial vehicles, or these drones may also be referred as remotely piloted aircraft. It is important here to know the difference between the drones and UAVs. All UAVs are drones, but all drones are not UAVs. For a drone to be a UAV, it is mandatory that it must have the capability to fly autonomously. UAV may be of a rotorcraft type of drone as well, or it could be a fixed wing drone or a VTOL kind of drone as well. I hope the definition of the drone is now very clear in your mind. Let us discuss the history of the drones. It was the year 1849 when the first use of the drone was recorded, and it was during the combat in which the Austrian military was involved, and they have used the balloons filled with explosive to attack the city of Venice. The first pilotless aircraft, named Hewitt Sperry automatic airplane, which was also then called as a flying bomb, made its first flight on September 1970 during the World War I. So this was the first pilotless aircraft that came into existence. In the same year, in November 1970, this automatic airplane was flown for the representatives of the US Army, and this thing led the Army to commission a new project, and that was to build an aerial torpedo. This later resulted in the development of a drone which was called as Catherine-Buck. The first flight of Catherine-Buck took place in the year 1980. In the year 1982, UAV bombers came into existence. These UAV bombers participated in the war between Israel and US. In the year 1983, Yamaha Corporation developed a remote controlled aerial spring system. Followed this event after a very long time. But in the year 2000, Yamaha has developed RMAX UAV. It was the same remote controlled aerial space system which was further modified into RMAX UAV and with an objective to make the agricultural work easier. In the year 2070, Yahang 184, the first taxi drone was launched. We can see from this history, timeline, how the drone, which was first used for the military purpose, has now shifted towards using the agricultural work and then finally for civilian applications like a first taxi drone. And the very latest was really the marvelous effort by NASA in 2021, which is very recent. Ingenuity Mars UAV was launched. It was developed by NASA. Currently, it is operational on Mars pallet. This Ingenuity Mars UAV is helping the NASA to explore the possibility of life on the planet Mars. We can see on screen the images of AHAG 184 during the launch, RMAX UAV spraying the fertilizers over the crops in military and defense, General Atomics MQ-9 Reaper owned by US Air Force, and then we have an image of a drone which is Ingenuity Mars UAV. Here, General Atomics MQ-9 Reaper is a fixed wing type of drone. Rest on are the Rotorcraft, multi-rotor drones. However, your Ingenuity Mars UAV is like a helicopter with a single rotor drone. A notable figure in the development of modern drone technology. As the drone technology has progressed from very beginning level to the current model level, there were efforts of many individuals at many organizations over the last decades. However, there are always some individuals who do something different and very big that it get notified and they are praised for their contributions. We have one person, Abraham Karev, who is very popular in the development of modern drone technology. He was an Israeli-American inventor and also an engineer. Karev is credited with designing and developing the Predator drone, which has become one of the most widely used unmanned aerial vehicles in the world. Types of drones. Drones can be divided into three basic types. First one is the fixed wing drones. We have already discussed about the fixed wing drones while discussing the previous chapter, and some part of it was also discussed in the chapter which was basic principles of flight. Rotorcraft drones can be further divided into two. One is the single rotor and second is the multi-rotor. Hybrid drones are also referred as VTOL. VTOL means vertical takeoff and landing drones. Drone and towing. In this picture, we can see various parts of the drones which are attached and they have finally took the shape of a quadcopter drone, which is actually a multi-rotor having 4 rotors or propellers mounted over the motors on horizontal planes. We can notice other than propellers, there is a motor and this motor is attached with electronic speed controllers. All 4 motors are attached with it. The electronic speed controller further connects with the power supply and the flight control board, which is a brain of this, you can say, this quadcopter. There are some more equipments that helps this drone to fly safely, and those are telemetry and GPS. Flight controller have many sensors installed on it, which we shall be discussing in the coming slides. So let us name these important components. We have a frame of a quadcopter, then motors, ESCs, means electronic speed controllers, propellers, battery monitor is there, flight control, which is also known as an autopilot, mounting pad, RC transmitter, RC receiver, Jeep connectors, power distribution boards, camera, gimbal, memory card, video transmitter and receiver, and the GPS mount. We can see these components in the image. There is one more component shown here, which is FPV goggles. These days, these FPV goggles are used by drone racers. There are sports events in which the drone participates in the racing competition, and the drone pilots have a FPV camera installed on their drone, and the view which these camera captures are directly transmitted on the screen of FPV goggles. These goggles can be, we can wear this over the face, and it gives us as if we are on board over these FPV goggles, gives us the feel as if we are on board flying along with the drone and experiencing the outside view. Frames are very important in designing the drones because frames are the one that holds these important components together, and these components should be very well separated so that they do not interfere with the functionality of each other. And also the frame should not be very power consuming. I mean, it should not be of very high weight. The weight of these frames are always kept at its minimum while designing, but it should never compromise with the strength of the frame. The materials which are used for drone frames can be a wood, carbon fiber, PCB, plastics, G10 or an aluminum. Let us talk about the inner electronics that are used to make this quadcopter or any multi-rotor drones. Motors are very important because it is the one which will convert its rotational motion into the forward thrust with the help of propellers. So these motors are a kind of propulsion system for the drone, or you can say an engine of the drone. These motors, which most of the drones that are being used currently uses, is a brushless DC motors. Brushless DC motors are different than brushed conventional DC motors, and they are chosen because of their high efficiency and last longer comparatively. The function or the working of brushed motor and brushless motor differs with each other. If we talk about the brushless DC motors, which are commonly right now being used by the drones, in brushless DC motors, there is a rotor, which is a rotating component, and the rotor is actually a kind of permanent magnet having north and south poles, and the stator part of the motor, brushless DC motor, carries coil bindings, or you can say coil arrangements. These coils, well, given the current, you can say the DC current energizes the coils present in the stator, and they becomes electromagnet. Then the rest working depends upon the interaction of the magnetic force of this electromagnet, which is a stator, and a permanent magnet, which is a rotor. And the stator, after getting energized, the north and south poles of the rotors gets attracted by the poles of the rotors, and so the rotor rotates. The continuous motion of the rotor is obtained by making use of several number of poles or coil windings, and how these windings inside the stator are energized. The electronic speed controller is used, which has a sensor to identify the location of the rotor's poles, and it energizes the coils of the stator in such a way so that a continuous motion of the rotor can be achieved. If we look in contrast to this, the functionality of brushed DC motors, you'll find that it is exactly opposite to the functionality of brushless DC motor. In brushed DC motor, it is the stator which is a permanent magnet, and the rotor is a electromagnet. There are carbon brushes which are in direct contact with the commutator in the rotor and transfers the electric voltage. This electric voltage creates electromagnetic field inside the rotor. By continuous flipping of the polarity of the magnet through the commutator, spinning of the motor is achieved. Electronic speed control. I was telling about electronic speed controller. Electronic speed controller has a kind of sensor in it that identifies the location of the rotor poles inside the brushless DC motor, and it also energizes the coils in the stator so that the rotor poles, north and south poles, gets attracted within that component and it rotates. So basically, it helps in developing the torque inside the stator for the rotor. This electronic speed controller also allows a reversing of the motor by just simply switching the two wires. On screen, we can see how the motor is connected with the ESC. Motor has this brushless DC motor has 3 wires that connects directly with the ESC's 3 wires respectively, and then ESC further connects to the battery, and the other wire coming out of the electronic speed controller goes to the receiver or flight control. Propellers can be 2-bladed, 3-bladed, 4-bladed, 5-bladed. It depends upon the type of operation for which the drone is being used. A racer drones has a different types of propellers and different designing. However, the drones which are used for aerial cinematography or videography purpose, those needs to be very stable and do not go for a very high maneuvers. So there, the selection of propellers is entirely based on different factors. So we can see how the propellers which are available in the market are. The propellers which are available in the market have their defined specifications, and it could be in the format of L cross P cross P or LL PP cross P. That means L here stands for the length or the diameter of the propeller, P refers to the pitch of the propeller, and B refers to the number of blades of the propeller. Pitch of the propeller can be understood in this way. If a propeller spins and completes one cycle, it executes one complete circle after rotating, the forward distance which it will cover in one single rotation, that distance refers to a pitch of that propeller. Some propellers have a lower pitch, some have a high pitch. So this lower and higher pitch values can affect the performance of the propeller. For example, if we see any propeller having mentioned on its blade Q5 cross 4.5 cross 3 V1S. So here we see basically the 3 numbers. First all, need not to be confused with, because it refers to a particular model of the propeller or a company name. So the first, the 3 numbers that we see here, it can be understood. The first 5 indicates the size of the propeller. In this case, 5 means the 5-inch diameter of a propeller. The second number is 4.5, which refers to the pitch of the propeller. And the last number is 3, and this refers to the number of blades on the propeller. A lower pitch propeller pushes the drone with less thrust, but it will always move fast. However, a higher pitch will mean more thrust available per revolution, and this is for achieving greater speed, but the controls are less comparatively. The number of blades also affects the flight efficiency. If there are fewer blades, that it means more speed, and less current draw or more efficiency. In contrast, more number of blades will refer to more control, but lower efficiency and lower speed. The another important component of the drone is the power supply, and which is a battery here. The type of battery being used currently is a lithium polymer battery. Lithium polymer battery has some specifications mentioned on its stock. We can see on the screen there is a digit written as 5000 mAh. This 5000 mAh refers to the storage capacity of this battery. Another word is 2S. 2S refers to the two cells this battery is composed of. 7.4 volt represents the cell count or a voltage associated with this battery. 50C refers to the discharge rating of the battery. There are many merits for using lithium battery over lithium ion. These depot batteries are much lighter in weight and can be made in almost any size or shape. These batteries have higher capacities, allowing them to hold much more power. These also have much higher discharging rings, means they pack more punch, that is the power. Demerits: shorter lifespan. Depots average only 150 to 250 seconds. The sensitivity chemistry can lead to a fire if the battery gets punctured. Need special care for charging, discharging and storage. Power distribution board, PDB. Power distribution board provides current supply to the various components of a drone, and it contains the circuit within itself. It also allows a very organized supply of the current to each component of the drone. Flight controller mounting pad. This flight controller mounting pad is used for the protection of the flight controller, because flight controller is a very sophisticated and very important part of the drone. It is a flight controller that has so many sensors attached with it, which identifies the location of the drone, movement of the drones, and then further it has a processing unit in itself that processes the data measured by these sensors, so that it can give command to the servos and electronic speed controllers, so that the drone can move as per the directions of the UAV pilot. Any disturbance or malfunction event of this flight controller will surely take the drone to get crashed. There are various types of flight controllers which are available in the market. We can see here the NASA MV2, NASR 32, R2 pilot is available, KK 2.1.5 flight controller is available, Open Pilot CZ3D. So there are various types of flight controllers are available in the market. One can choose it as per their requirement. Here is an example of a KK 2.1.5 flight controller on the left hand side and R2 flight controller on the right hand side. I was telling about the sensors which this flight controller has. There is an accelerometer sensor, there is a gyroscope sensor, compass sensor for navigation. There is an IMU unit. These accelerometer, gyroscope, compass together forms a unit known as IMU unit. So there all three may be integrated into one component also. There is a barometer to measure the atmospheric pressure, and there is a GP to measure the location of the drone for navigation. I hope the important parts in electronics that are used in the drone. Intro to mission planning. Mission planning for drones involves a series of steps and processes to ensure a safe and successful flight. The main steps involved in mission planning are defining the mission's objective, conducting a site survey, choosing the right drone, planning the flight path, establishing communication and control links, preparing for takeoff by conducting a pre-flight check of the drone, as well as verifying that all necessary permissions and approvals have been obtained. The mission planning helps to enable the drone to fly autonomously. There are several software which are available for mission planning in the drones. Some of the most popular include DJI GS Pro, Export D Capsule, UGCS, Mission Planner, Drone Deploy. Mission planning gives you the better control on your drone, and it minimizes the emergency situations that may occur during the flight, and also it gives you a better control to retrieve your drone in the case of emergency. Instrument flying and navigation is the another feature which these mission planning softwares provides you as a tool part of your ground control system. Instrument flying basically refers to the process of operating your aircraft means drone using only the information which is displayed on its instruments or the details which are available on your screen without relying on visual references to the outside environment. This is typically necessary when flying in conditions of the reduced visibility such as fog, clouds, or maybe a heavy rain in case of emergency. Navigation, on the other hand, involves determining the position of the aircraft and determine its course and speed. In instrument flying, navigation is primarily performed using instruments such as airspeed indicator, altimeter, attitude indicator, and the heading indicator. Applications and operations of multicopter. Multicopter drones have a wide range of applications and are used in a variety of industries. Some of the important applications which are good to recall here are aerial cinematography, means capturing photos and videos through your multicopter drones, as they have very high quality cameras with a gimbal which provides a very stable recording. In the case of agriculture, drones are used in agriculture for tasks such as crop mapping, monitoring the crop health, identifying potential yields, reducing problems such as pests, disease, and water stress. In the case of inspection and maintenance, these drones can be used if there is a need to inspect bridges, power lines, pipelines, and other critical infrastructure or signs of damage or wear. During search and rescue operations, deliveries can also be done using multi-rotor drones. Surveying and mapping, environmental monitoring are the other few of the applications of the drone. Drones can also be used for traffic management as well, to monitor how the traffic on roads is moving. There are various plus and minus points of rotorcraft drones, some positive, some negative. Every technology has negative points and some advantages. These multi-rotor drones has a very good versatility, can be used for various types of operations. Their efficiency is good. It is very cost effective and much safer to operate. Demerits are again the regulations which need to be followed. Flight time has a limitation. It is very sensitive to the bedroom. Of course, it could be a factor in disturbing privacy. So it should not be violating the privacy of the citizens in the city. These negative points associated with the drone needs to be overcome by some other technologies of the drone that should act here as a supplement, and it may, if not taken care of the regulations, may interfere with the other full-size aircrafts and can affect their safe operations. So with this, I would like to thank you. We'll meet you in the next session.